I'm Rob Guttrow from NASA's Goddard Space Flight Center, and here with me today is Dr. Jeff Halverson. He's a professor at UMBC, Maryland, and also a NASA hurricane research expert. Good morning, Jeff.
Hi, Rob. How you doing?
Good, thanks. We're here to talk about NASA's new hurricane mission, GRIP. We're going to get a grip on hurricanes here with the Genesis and Reintensification Processes mission. Can you tell us a little bit about GRIP, please?
Well, the GRIP, as you said, it's an acronym for an experiment that NASA is doing, the Genesis and Rapid Intensification Processes. Genesis means birth of hurricanes. Rapid intensification means deepening very quickly. Here you see NASA's flying laboratory, the DC-8, and here you see another new aircraft that NASA is using, the Global Hawk. The Global Hawk's a drone. There's no pilot in it, and it flies at 60,000 feet. And so we take these high-altitude aircraft, we put them in the upper levels of the hurricane where it's hard to get data, and the Global Hawk can stay over a storm for 26 hours. That's a long time, and that's going to revolutionize the way we do hurricane science, because now we can follow a storm as it goes through all its changes. We're not going to miss a beat on a storm. It's going to revolutionize the way NASA does it.
Now, what's the difference between hurricane hunters that NOAA flies and the NASA GRIP aircraft mission?
You know, I think most of you may be familiar with the hurricane hunters. They've been doing this for years. They fly the aircraft into the storm, but they go in at the low levels, right above the ocean, 10,000 feet or so. That's a great place to be to collect data. Now, here you see we're in the upper levels. We're looking down inside the eye of Hurricane Earl from inside the eye at 40,000 feet. And there's a lot of important things that happen in the upper levels of the storm. Satellites can tell us a lot about the upper levels of the clouds, but here, this is a historic picture. This is the first time we took an unpiloted drone over the remnants of a hurricane. That's Hurricane Frank over the East Pacific, and that's from 60,000 feet. There's no pilot in that plane, but we're collecting great data from the upper levels of the systems, and that's important for hurricane science.
Now, the Global Hawk, this is the first time an unmanned drone has ever been flown into a hurricane. Is that correct?
That's correct. That's right.
Now, this mission runs through the end of September.
Right.
And on September 2nd, we're flying the unmanned drone. Is that right? Are we going into Hurricane Earl today?
We're going over the top of Hurricane Earl. This aircraft took off from Southern California very early, and now it's out over the storm. It's flying patterns over the top of the system. It's going to stay out there over that storm for 10, 11 hours, and then it's got to go back to California.
And typically, how long do hurricane hunters stay out there?
Hurricane hunters will go out for 6 to 8 hours, and they got to come back in because they need fuel, they have crew on board, and the crew can only operate a plane for so long. You have what's called duty hours, right?
What about the satellites that are supplementing data to this mission?
Well, for many, many years, NASA has had satellites up measuring all aspects of the Earth system, and hurricanes are no exception. Here we see, looking not just at the tops of clouds, but peeling away those clouds, a CAT scan, right? We're taking CAT scans of hurricanes now. We're also measuring the temperature of the skin of the ocean. Look at the warm water, just waiting for storms to develop. So these are new ways of looking at systems, and here we see supercomputer simulations. These are numerical models, mathematical models that take all that satellite data, all that aircraft data, put it in, and you run the model and you learn about the physics of these storms. So NASA's taken us places we have never been with hurricanes.
So some of the factors that we're looking at for Genesis of a tropical storm would be sea surface temperatures, as you mentioned.
Right.
What about the upper level winds?
The upper level winds are really important. You can have lots of energy in the ocean and those clouds bubble up really deep, but if the tops of those clouds get into strong winds, wind shear, the tops of the clouds can literally be blown off the bottom, and you can't get a hurricane unless you stack everything up vertically. So here you see a satellite picture of the winds just blowing those cloud fragments away to the north. And if you get too much of that, that actually causes a hurricane to weaken.
And we have tropical cyclones out there now, like Fiona and Gaston. Are there any plans to fly over those storms?
Well, we have to wait for the storms to get close enough to where we are. We're the DC-8's in Fort Lauderdale, the Global Hawk's flying out of Southern California, and we have a third aircraft, the WB-57, which flies at 60,000 feet with 2 pilots. That one's coming out of Houston, right? But so we let the storms move towards the West Atlantic, and then we'll go hunt them. So yes, it looks like we're going to get others, Fiona, Gaston, maybe the other storms too.
In closing, is there anything that you'd like to say about the GRIP mission, how unique this is?
I think it's very unique, the fact that we're sending out an unpiloted vehicle. This is where the revolution is going to take place. Now this is going to be the new way to study hurricanes, and we're going to move all the operations to Wallops in a year, and we're going to start flying these drones on a regular basis every summer.
Wow, sounds really cool. Thank you, Dr. Halverson.
Thank you.
Rob Guttrow from NASA Goddard Space Flight Center.